Hi everyone. I'll be presenting my approach for the hackathon uHack Sentiment 2.0 by Ugam, which was hosted on MachineHack. Uh, I assume that many of you might not be aware of the problem statement, so I just want to spend a few minutes just explaining the problem statement, what was given to us as participants, and then I'll deep dive into my approach. We were given a data set of reviews from customers. Currently, people write a lot of things online, and as business, I think it's of utmost importance to understand what the customer is trying to say. To say that there are different parameters which you can try to which you can measure what the customer is trying to say. Initially, when the hackathon was released, it looked pretty simple that you're given reviews and you need to predict the polarity, which is the sentiment. And I feel sentiment is something which is already a solved problem. But there was a twist in the hackathon. We were not just given one target variable; we were given 12 target variables. So as you can see that there were 11 topics and one polarity variable, target variable, which we had to predict. This on the face value first looked like a multi-class classification problem, but that also wasn't the case. So if you take, for example, the third review, right, you'll see that functionality, usability, and polarity, all three of them has one, which means that all three, they can be multiple target variables for the same review, which can have a flag one, which makes this problem either solvable by two approaches. Either you can solve it using individual binary classifications, like using 12 models, or you can try to frame this problem as a multi-label classification problem. Just to give an idea of how the dataset looked like, there were around 6.1K rows in our training dataset. We were given around 2.6K rows in our test. Uh, in the label distribution, as I mentioned, that every data point had multiple labels, maximum being 5, and the one with the most frequency was 2. Uh, in terms of categorization across different review types, functionality and usability quality had the most number of data points available to us. We had a very less data points for delivery and customer support and material. With this small base about the problem statement, now I'll just jump into what my approach was for solving this. I'm sure looking at the picture on the right side, many of you might have seen this. This is the transformer image, which is taken from the paper, the attention, which is all you need. And yesterday, the Panjan Sarkar, I think, also gave a session on this, on demystifying transformer in NLP. So as what the transformers was my main model which I used for solving this problem. In terms of library, what I used was simple transformers. In case if you haven't utilized this for your implementations, I would highly recommend it. Uh, Coming to the task multi-label, initially when I started the hackathon, I also approached this using a binary classification method in which I tried making 12 different models. But the main reason why I shifted to a multi-label way of doing things was majorly because of time. Because let's say if as my validation strategy was a k-fold strategy, and I didn't want to compromise on that. So if you have 12 models and you want to do a 10-fold like let's say a k-fold validation, that is almost equivalent to like 120 mini models. And let's say if you have an epoch size of 5 or 6, you can imagine how much time it was taking for me to train that. um, as soon as I shifted to multi-label, the training and inference time both dropped, and that was like the key reason I stuck to this for developing all my different models and even my final submission. I tried different kinds of text cleaning, but I did not gain any advantage in the cross-validation scores, and that was mainly, I can say, because of few reasons. Because transformers as a model inbuilt has a lot of things which really help you in terms of not doing text cleaning like dedicatedly. Few of things like it has byte pair encoding, which basically helps you not do lemmatization and stemming on your own, as it does it like by default for you in the sense using the byte pair encoding. Few other things which it takes care of is it has different models for cased and uncased like text. That also helps you in a way. And secondly, you don't really have to worry for removal of high frequency words, which you generally do when you use TF-IDF or word to word kind of models. The reason being that the attention principle in transformers help you look at words which are important in terms of the output, and not basically words which are very common in the data. Because of few reasons, I feel that text cleaning wasn't really required and it didn't really help me. I did a lot of iterations, multiple iterations using different models, which had different batch size, sequence length, fold epochs. And finally, I made my final submission, which was an ensemble of all of that. I'll come to that next. In terms of architecture, in my final submission I made around 8 models. These are not the ones which I directly ended up on. I made around 19-20 models over the iteration of 23-24 days, which was the duration of the hackathon. These were the final 8 ones which I found relevant enough to be utilized for my final submission. You will see that all of them have different batch sizes. A few have different folds, few have different models. So there was a lot of experimentation which I did to look and looked at my cross validation and my leaderboard score to understand what was working well and what was not. Uh, there was one specific thing which I stumbled upon, which was a flag sentence embedding. This was a specific model which is like a fine-tuned version of Roberta Large using more training data. This was an outcome of a community event which Hugging Face did 6 months back. I remembered this and I used this, and this gave me a best result. So Model 8 itself was strong enough to get like a good rank, even if I had not done a blend of all these 8 models later on. Finally, I did like a blend of all these models. On the face value, it looks like a bit complex in the sense that how did I arrive at this kind of a blend? But given the fact that these models were not available to me at once, these were an iterative over multiple weeks, like 2-3 weeks as the competition progressed. So and there was a restriction on the submission limit. So I had only 3 submissions to make every day. So what I did was I made 2 models every day and used one submission to do an ensemble. Uh, consi- and as day passed on, I had few ensemble models which are performing well, and hence I wanted to use them as a collective blend in the end. Few things which I kept in mind while joining all of them was I tried keeping a similar model outputs which have just few parameters different. So let's say if there's a Roberta base and Roberta large, I won't directly join them. I might join Roberta large and large first, and then join base and large just for diversity. And there are a few models which were given more weightage based on their local cross validation and LV score. Multi-label approach was something which definitely helped me in allowing me to do so much experimentation, and it really reduced my time by 50%. It was earlier taking me around 12 to 14 hours for training 12 binary classification models, whereas it took me around 5 to 7 hours when I switched to a multi-label approach. Uh, as I earlier mentioned, Model 8 was something which was sufficient enough to get a good high rank, but I definitely wanted to be sure. In terms of productionization, Model 8 would have been a right choice if it had been an office setting. Uh, Thank you. This was all my approach. I would like to thank MachineHack, Ugam, and Analytics India magazine to collectively to give me a platform to present at MLDS 2022. You can reach out to me on LinkedIn, and I'll be around at the lounge, and we'll take questions in the end once everybody presents.
Particular hackathon was, I guess for me it was very competitive. Okay, so it was, and a great learning experience also. Okay, so as Salil has actually mentioned that what basically this problem statement is there, and what are the things that he has tried. So let me present you my solution, my approach towards it. Okay, so coming to the agenda for this, so I have just divided the topics into problem understanding, the data understanding, how did I pre-process the data, and what is my model building and evaluation criteria, and what are the applications that we can see with this particular data set, in a business case scenario. So moving forward, so basically this is just the problem understanding to which I have presented it to you. So for us, the challenge was a natural language text to classify those reviews. So our main objective was here is to classify those into several topics, and this is kind of a multi-level classification problem, which is actually kind of a new one. So that particular complexity lies within it. Okay. Oh, and all in all, for that particular customer review, whatever. So in that, we also needed to have the polarity that what kind of sentiment actually the customer is actually reviewing about. So for me, the problem understanding was, I had to make sure that it is a kind of a multi-label classification than it has to be, it had the essence of sentiment analysis as well. And with respect to metrics, so the metric was related to a log loss. So in this particular chart, which I've actually mentioned here, so this actually shows that what kind of topics that particular review has. Okay, so as we can see that the functionality and quality of the highly rated reviews. Okay, for any of the customer complaints or grievances that he has. Then moving according to that, let's have a look at what kind of data that we have, because understanding the data is pretty much important, accordingly to how you can model the solutions around it. So I've presented to you two kind of simple review. Okay, so if you can see that here we do have the review text, and how these particular text and how these tokens are actually linked to these particular topics. So that's how, and what is basically the polarity of it. So basically in this particular slide, what I'm trying to show is that let's say that you have sturdier and you have the stronger proof. So you need to understand this particular kind of data, that what kind of data you have and what are the main tokens or the spoken points that you can actually map to it. So this is the first and the most important part, in which you have to first of all understand data before any of the hackathons. Okay, and that gives you quite an understanding that how you can model, the data, or what is the approach that you can take. Then moving, forward to my next slide. So this is a data pre-processing pipeline that I've used. So I'll just start from the beginning. So for me, creating and participating in this hackathon. So first of all, what I try is, a kind of a baseline approach, okay, to understand that where are we from. So it is kind of a naive approach that we usually took. Okay. So for this particular hackathon, I started with a tree-based modeling strategy. Okay. So first of all, I created two pipelines. Okay, which first was based on the feature engineering aspects of the text. So let's say that you have a review. So what kind of what is the length of that particular review? What how many the punctuation counts are there? What are the pause stacking features? Okay. What are the the topic based features that I extracted from that particular text? Then in the text cleaning and processing approach, so how did I, basically I used to remove the stop words, the punctuations, and then, using the stemming and lemmatization for it. And at the last, to create my modeling features, okay, for this naive approach, so I've used the TF-ID features using n-gram technique, okay. And we have the raw features engineered, which was the word count and everything. So this is my first pipeline, okay, which I intend to use in the modeling approach. Okay, my second pipeline was for the simple transformers, and I guess Salil has actually told us that more about what simple transformers are. So I'm not going into that. Okay, but for my approach, the text cleaning that I actually had done, okay, was related to a little bit of stop words, the punctuations, and some of the spell checks to correct that particular the context and to maintain that semantic part to it. Then moving on ahead, so I did some feature processing, okay, to format the particular review and the labels around it, so that it can be easily implemented using simple transformers. Okay, so after that I had two separate data sets, okay, which I can use to model it around. Okay, so this is something around what kind of pre-processing that I have done. Now moving forward to the model building and evaluation. So as I said previously, that I had this particular two pipeline approach. Okay. So first we have the pre-processed data, which is based on TF-ID, TF-IDF, and the engineered features, and we have another data which was related to the transformers. So in my first approach, whenever I start hackathon, so I had this first approach. So I used a multi-label classification methodology using one versus rest classifier and light GBM. Okay, so that actually gave around a score of 3.37 log loss in the public leaderboard, and that was actually quite good with all the features that I've engineered and everything. So that is actually a good approach, in any of the hackathon, or any of the analysis that you did do. Okay, so that is the first approach that actually you should take. Okay. Then with the hackathon perspective, as it was really very much competitive, so what I did, I went ahead and used simple transformers. So I used a different, cascade kind of models, okay, with which I had Roberta large, then we have Roberta base. So using different epochs, different learning rates, and the different max length. Okay. Then my next approach was to weight these particular ensembles, okay, based on the class probabilities, and using the mean local skew sort as to reduce the variance around it, because these are separate models, separate architectures, okay, which will provide you different kind of solutions. Okay, so if you ensemble them, so that is a perfect approach to at least to reduce the variance around in an unseen kind of data set. So these are just the results that I've actually posted here. So if it is it is, if it is a kind of a productionized environment, so the best approach would be go with multi-class classification problem. So for me it actually took around, I think, minutes to give this particular prediction. Okay, and this is the best approach which we can easily create a pipeline with the raw engineered features and everything, and it can be easily productionized. Now coming to the transformer, we know that it is a kind of state of art architecture, okay, and it gave the best results for me. Okay, so it was around 2.8 to 3.0 log loss, and with the ensemble of these two based on the um, weighted ensemble, so I was able to reach the rank 2 for this particular hackathon. So yeah, moving forward. So as you know that in any of the hackathons, the first thing that we actually want, okay, as as a business, consultant or anyone that wants it, how can we, use this particular data set, or what is the approachability, what are the recommendations, or what are the business use case applications that we can apply for this particular data. Okay, so I've actually just jotted down few of the applications that I deemed which are really necessary and which can, improve business outcomes in a long run. So first, few of them are, the product improvement that, for example, the regarding one product. Okay, so you do have, several customer reviews. So based on that, you can enhance, you can, model around it so that this particular product is actually selling more. Moving ahead with this particular, let's say that you are having a product which has kind of a negative review. Okay, so you can do the remediation around it. Okay, then we also can have a product recommendation system on as to how these particular sentiments that we are getting, so we can do a kind of analysis over semantic analysis over that particular data. We can build recommendation system around it. Coming to this customer review analysis, so basically based on whatever the customer has actually reviewed around it, we can create a kind of a dashboard or this kind of scenario in which we can gain that particular customer experience and help them out in such a manner. Then we also have this urgency detection methodology in which if there is a kind of, if we have certain topics like price and they are kind of urgent, and in a negative polarity, then you can do an analysis and model around it so that in the future these kind of business will actually help anyone to reach a very good rapport around the customers. Then we can also implement these kind of algorithms into chatbots to transfer the grievances based on the review topics to different teams. Okay, as kind of an automation suite. Okay, so and these are some of the business applications that I thought that are really very important based on the several topics in the data set that I had. So I guess that's it from my end. So thank you, and thank you MachineHack for United Media Magazine for this presentation.
So what I'll be doing is just be starting with whenever you get any problem statement in any hackathon, the first thing is why that problem statement was given. What is the benefit of that problem statement? So as Salil and Rajat have already mentioned that the problem statement is this. Basically, you're giving customer sentiment, positive and negative, and apart from that, what topic he is speaking on. So let's say if I'm a customer, I want to buy a phone. I go on the Amazon website. I see for a particular phone. First thing what I do is basically I look at the rating. Basically, I want to understand what are the sentiment of the customer. Basically, whether they are happy, sad, not happy, etc. And after that, I would look at the certain specifics of the phone, basically camera or battery, etc. So the same kind of problem statement is over here, basically. But now, rather than looking from a customer's point of view, I'll be more looking from the organization point of view, because I'll be hired in the organization. I want to understand how I can improve customer experience. So basically, if if I get to understand which are the positive and which are the negative sentiments, basically reviews of the customer, I would need to understand why, if it's a negative, people have tagged it as negative, which category does it fall into? Basically, people are not happy with the price, people are not happy with the features, not happy with the qualities, etc. Which thing? And if I once I understand that thing, I would be more. It would be more easy for me to help customers in their what they actually want. Basically, if they help them to understand better. For example, if the price is very high, a lot of people are giving a negative feedback about a particular phone or something. I would not put that on my website because I know if I keep putting on phones like that, there are multiple players in the market. People like if Amazon, there is like a Flipkart. People would move on to the other platform. So I would need to understand people's requirements and basis that I would need to keep the things on my platform. So this will help me to understand my base for product enhancement as well as better pricing, as well as take necessary actions to improve customer experience as well as customer retention. Otherwise, they would move on to the other platform because nowadays you have plenty of options. Now, this what other thing I thought is basically how where all it can be used. So, for example, in movies also, basically when you have let's say you are watching a movie, you hear some movie, you first look at the rating, the review of the movie. Basically, what is the rating, etc. And basically, then you look at okay, what is the genre? I mostly like action movies, so whether I would like that movie or not. Same kind of thing. Another thing is basically the call recordings in call center. Basically, what uh, when your agent speaks to the customer, whether the customer is happy or no, and if he's not happy, what is wrong? Basically, the agent misbehaved with the customer, or the agent did not speak properly with the customer. Whatever the reasons is, we need to understand that. And similarly for the election campaign, so basically, like the bidden analysis. So basically, if he is winning or losing, let's say if the analysis was more towards the losing part, the people who don't like it, we would need to understand why do they don't like it. People normally speak about the health infrastructure, or people normally speak about the education. And if they speak about that thing, what do they not like? So basically, using that, I can understand and take actions accordingly to improve my customer experience. So this was more or less the applications of learning when I first saw the problem statement. Then I looked at the data. So as I said, the first thing is the polarity of the customer sentiment. So if you see, there are around 4,770 positive and now 1,366 negative sentences. Now I wanted to understand. Basically, this is called as a coverage analysis. This I wanted to understand how many of them are speaking about, let's say, component and they are positive. Similarly, how many of them are speaking about component and they come in negative. Now, if you see both the columns, the first row, components, there are very less people who are speaking about component but are positive, but mostly it is negative. Now I need to understand what is wrong with my component. What is the reason they are saying negative about? So basically, what when I looked at the data, these were the kind of, basically it's a word cloud. This is just a 1 gram. You can expand it, but basically what I saw is basically there is a product called as nail gun. Nail gun is basically where when people are not happy with the parts in it, the nails, etc. And second is there's a toilet. People are also ordering toilet, and that also they're not happy with. So basically, if I know my customer base is not happy with these kind of products, that kind of feedback I can provide to whoever is selling it, and then accordingly they can make the necessary changes. Similarly, I did it for delivery and customer support as well as this quality. So these are the 2 3 things I just put on the slide. But as in, you can understand each of the components and try to gauge what your customer wants and accordingly take actions on that. So for the data pre-processing one, that was a basic thing. I converted all reviews to lowercase. I converted the short form, basically can't to cannot, I am to I am, I to I will. Basically, because the reason is I would be training a BERT model, and the BERT has certain words which it has learned. Can't is not a sentence. Cannot is a sentence. If can't is not a sentence, what it will do is it will split it into two halves: can and apostrophe t, because it can't find that exact uh, word in the vocab. I removed punctuations and numerics because that was not giving me any information, and I stripped white space, the basic pre-processing. Now the next thing which I did was basically put a language model. Now what exactly language model is? Basically when we start, when we go to the school, the first thing what we learn is, let's say, English characters. Then we learn numbers, 1, 2, 3, 4, basic maths. Now, using that basic maths, we learn algebra, we learn geometry in the high school, etc. And then when we go move on to college part, we learn more on the real analysis part. But let's say if I ask someone to study about real analysis and answer some question without him or her having any knowledge of algebra, geometry, or not even numbers, it would be very tough for that person. Similarly, the word model, it has understanding of the English language, basically the relationship between the English language, but it does not have understanding the relationship among the words in the review section. Basically, what kind of words do people use over here, and so that is the reason we need to make our model understand the relationship between the words which people write in reviews. So that is the main task of language model. And so basically, I used this active bus from Hugging Face. This is a pre-trained model, and I train again on this model. Now, why did I choose this? Is basically this is based on a paper which focuses on solving 3 review-based tasks. Basically, review, reading comprehension, aspect extraction, and aspect sentiment classification. This is more from the e-commerce domain, and it's a generalizable solution for any review. So that is the reason I use this as a pre-train. So it is equivalent to I'm using my algebra geometry knowledge as a pre-trained thing, and I'm training myself to understand what is real analysis. Similar thing I did it over here to make my model understand the relationship between the words in the reviews. So this is the link to the paper. Very good paper. You can have a look. Then I basically took a birth-based classifier model. So whatever the weights I have learned from the language model, I used it as the initial weight for my birth model. So like whatever learnings I get from algebra geometry, I'm using it as a initial weight for my real analysis part. I developed 12 models, one for each target. The reason being, uh, I had I was caught up in other stuffs as well, and luckily I had collab pro plus subscription, so that was an additional advantage for me, but that is not advisable in production. It takes a lot of time, trust me. uh, then I tweak the different max length for each target. Basically, this is one of the hyperparameters, and this cross validation strategy. Basically, I use a 5-fold cross validation strategy along with early stopping and weight behavior to avoid overfitting, because there is high chance that your model can learn whatever is there in the training data, not generalize well. So I faced a couple of issues in one of the targets. So that was the reason I had to make sure that it does not overfit on any particular target. And this was basically the cross validation score for each of the 12 targets. You can see functionality and quality. They have a very high CV score. One of the other reasons being is basically if I show you the data understanding part, as I said, if you see over here, functionality and quality in positive and negative is basically 40-40. So in the training data itself, it did not have much differentiation per se. So that was the reason of me getting a high series log loss. Basically, this is a log loss score of high above zero point 0.2, but remaining every had a good CV score, and this helped me to land at leaderboard score of 2.778 something. That's it. Thank you so much.